In lesson 2 of Unit 7, we have to learn all of the ArrayList methods. They're all listed here in the notes I gave you from REPL. This comes straight from the course and exam description. It might be easier to actually read them in the quick reference. Remember, you get this sheet on test day. Previously, we've covered a lot of this stuff. All of the methods of the string class are here. Whatever you see on the left is the return type. So like we've seen length and string returns int, string gets returned from substring, boolean from equals. Also, you might remember way back when in Unit 2, we learned about the wrapper classes integer and double. At the time, I probably told you, like, oh yeah, we're going to use those in ArrayList. Now's that time. Okay, here's our math class methods. And then here's our ArrayList class. So we haven't really covered any of this yet. There's 6 methods we're going to look at today. This is our last big syntax day of the year. So once we get this down, there's just some little things we have to kind of cover to finish the year off in terms of syntax. And one thing that's kind of weird here is that weird, mysterious letter E that's showing up. So E is what we call a generic type in Java, and it's going to get replaced with kind of whatever we want it to. So if we had an array list that held book references, then E would become book. If we had an array list of string, it would become string. If we had an array list of triangle references, it would become triangle. So when you type your array list, then you're saying what the return type of the method is. We're only going to use typed list in our course. So we're never going to have anything that wouldn't be typed where we'd have to cast things on the way in or out or whatever. Now, everything's going to be of a given type. So I've got some examples for you here in the notes. And the first one we're looking at has a string type array list. So that means that for all those methods that we were just looking at, imagine replacing the letter E with string every time. If I change the type of my list to old type double, wrapper class double, that's what E would be, okay? And so on. So if we look at these methods real quickly, don't blame me, but for whatever reasons, we don't have a link method. It's now called size. So you got to remember that with array list, we use dot size, and they'll tell us how many elements there are as an int. There's 2 ways to add to a list, okay? The default way here is it just automatically goes to the end of the list. So if you don't specify where you want to add the item to, it automatically gets appended to the end. Or you could say where you want to put it. Now, every time we call the add method, the list gets bigger by 1. So the add method is kind of like, let's say in my roll sheet for a certain class, I have 30 students, and then I get a new student. I could put that student at the end of the list, but if my list is alphabetized, I might want to put that student in at index 5 or 10 or 20, depending on where they belong. This method could do that. This method could put them where I want, and if I put them at, say, index 8, whoever used to be at index 8 would now go to index 9, and whoever used to be at 9 would now go to 10, and so everybody moves over 1 to make room. When you're using this method, you can only put in indexes from 0 to size, inclusive. Okay, so you can add to any existing index. Everybody will move over 1 to make room, or you could add them directly to the end of the list. So if I had a size 5 list, it'd be indexed 0, 1, 2, 3, 4. I could say I'd like to add to index 5, even though there isn't an index 5, they would be taking it over. Now, in that case, if I had tried to add to index 6, that's an error. Okay, you can only add to an existing index or to the very end. If you go beyond that, then you're out of bounds. Okay, we have a basic accessor method called get. Anytime we'd like to retrieve something from the list, this is what we'll do. It will come back to us as the type that the list has been declared as. All right, that's the E showing up again. And then we have some pretty interesting methods, set and remove. These methods kind of pull double duty. So they're looking to modify the list, and they're also looking to make a return. And so this can be a little confusing. The set method, I kind of wish they had named it replace, but they named it set. So that's what we're stuck with. But that's what it does, is it replaces something in the list. So earlier I was talking about putting in a new student. If I had used the add method, I would have put them in, everybody would have moved over and made room for them. If I had used the set method, whoever went into my roster, now somebody's got to come out. So it's like I'm getting a student and I'm losing a student at the same time. And this method's return would actually be the student who came out of the list to make room for this new student. So this method's going to remove somebody from the list and add them. And the person that, or the object, I should say, that gets removed gets returned as a result. And it comes back again as its type. Okay, and you can only set existing indexes. So if you step away from an existing index, you go out of bounds, and you don't have that size option like the add method does. It has to go where there actually is an object right now, because it needs to return that removed object. The remove method, okay, earlier I said the add method always makes the list get bigger by one. Now the remove method always makes the list get smaller by one. So you're always going to see the size decrease by one when you call the remove method. There's actually more than one remove method that belongs to ArrayList, but in our course, we're only using this one we remove by index. So I might say I'd like to remove the items reference at index 5 or 10 or whatever. Everything to the right would then shift over one and get a new index to fill in that gap. Okay, and that's part of the size changing. Again, this method pulls double duty because it's also returning. So it's modifying the list and it's returning the item that gets removed. So I've got several examples over here. Let's just take a look at this first one together. So I've got an array list that's type string. So again, all those letter E's get replaced by string. Let's go ahead and let's print a few times just to kind of see what's happening in between here. So I'm going to do a print where I'm going to print the veggies list. I'm going to implicitly invoke the toString of array list, keep in mind, okay? And then I'm also going to go ahead and print veggies size. So unfortunately, they changed the name on us, right? It's not dot length, now it's dot size. And if we take a look at that print right there, we're going to see something kind of interesting happen. We see just a double bracket appear. Okay, so we don't get, that weird memory address like we would with an array. We're trying to get a formatted list. There's just nothing in it right now. That's why its size is 0. Let me drop down a few lines and put that same line of code in. And now our size is going to be 3 because we have carrots, broccoli, and lettuce. And notice how it kind of printed like a nice looking list for us, right? I put those brackets on there, put the commas, I put the spaces. So that's nice. We don't have that option in arrays. In arrays, we'd have to do an import. We'd have to call arrays.toString, and that's not even part of the AP exam. But with the list, you get a nice, easy print, okay? Another thing to note here is notice how like broccoli went after carrots and lettuce went after broccoli. So the order is crucial here. I can almost guarantee you're going to have a question like this on your AP test and the multiple choice. They're going to add some things to a list. They'll probably call set and remove. And then you'll have to say like what the state of the list is when you're done. So the order is crucial. So broccoli went after carrots, lettuce went after that. Remember, the default nature of the add method is to always throw the new item to the very end of the list. Okay, well, here I'm calling the add method with its other use. Okay, this time I said where I want to add. So I'm adding green beans to index 2. Right now, lettuce is at index 2. So if I put green beans there, notice green beans took over index 2 and lettuce moved over. So again, let's kind of look at the indexes here and highlight exactly what just took place. So carrots was at 0, broccoli was at 1, lettuce was at 2. And when we said, let's add green beans to index 2, notice that some of the items got new indexes now, not carrots, not broccoli. But when green beans took over index 2, that means lettuce had to move over to index 3. The size of our list would now be 4. Okay, whenever you add, the size goes up 1. Now, if I add cauliflower is at the end of the list. It's now size 5. All right, here's our first call of the remove method. So in calling the remove method, there's a few things going on here, but the bottom line is, notice carrots used to be at index 0. It's now gone. Now, in addition to carrots being removed from the list, okay, we also notice that broccoli got a new index, used to be 1, now it's 0. Green beans got a new index, so did lettuce, and so did cauliflower. I never specified that cauliflower was at index 4. Now it's at index 3. Okay, so everybody had to shift over. The size of the list went from 5 back to 4. When you add, the list gets bigger. When you remove, the list gets smaller. Now, there actually was something else happening at this moment, but we didn't really capitalize on it. When we called this remove method, there was a return being made. So even though we don't see it here, there was a return. It actually returned the string carrots. Okay, I'll show that to you in a minute. Here I've called the set method. This is our first time seeing it. Remember I said this method's kind of misnamed. I think replace would have been a better name for this method. But what the set method does is it goes to this index, in this case 1, where I currently see the string green beans, and it replaces it with squash. Now, notice what it didn't do. It didn't move green beans over to make room for it, not like the add method did. It just got rid of green beans. So it removed green beans and it added squash. The size of the list didn't change. The size of the list is still 4 at this point. Like the remove method, this method actually did double duty. Not only did it replace green beans, it also returned it. It's just I didn't do anything with the return. My method call just didn't capitalize on that. I could have made this a little bit differently. I could have said like, hey, let's call veggies set on string S. That's a little bit different. Okay, see string S, I'm saying I'd like to initialize string S with whatever this method's return is. So whatever this method returns is going to be used to initialize S. Okay, well, now again, what's happening here? Well, index 1, which was currently squash, is being replaced with asparagus. Lettuce and cauliflower stay the same, so does broccoli. Their indexes don't change, right? We're not changing the size of the list, we're replacing. Squash is out, asparagus is in. But something else happened. Squash got returned by this method. So S just got initialized to squash, and we actually see it here now. So if you print it, notice right there that squash printed. It didn't print the list. I didn't ask it to print veggies, the whole list. I just said print S. S is simply the item that got returned. Now, also, I'm able to initialize S and declare it as a string because the type of the list is string. If the type of the list had been book, I would have had to declare this as a book. If it was a double, it'd have to be declared as a double. Years ago, it was a little bit trickier because, like, if you didn't have a type on your list, you had to cast everything on the way out. But we don't have to worry about that now. Kyle's Word has promised us all lists are going to be typed, so we don't have to worry about casting on the way out. If I go back to that remove method real quickly, and I did something like kind of similar, let's say I said string v equals, that's not going to change anything that you see over here. These methods are going to perform the exact same way that they were. The difference is the item that got removed, which remember was carrots. Carrots used to be at index 0, and now it came out. And when it came out, and let me just move these indexes over so they line up again. When carrots came out, and broccoli and green beans and everybody moved over, now here's that double duty. Not only did we remove carrots, but we also returned it. And so carrots would be used to initialize V. And I could show that to you right here if I was to print V as well as S. Oops, I think I got a little bit off there. Let's try that again. All right, so now I'm predicting that it's going to print carrots, then a space, and then squash. So see over here where we had highlighted squash earlier, we should see carrots there first, and then the squash string. Okay, because again, carrots was return. The remove and set methods are weird. You may have to play around with them a little before you fully get it. They're doing two things. They're doing their action, they're removing and they're setting, replacing, and they're also returning that item that got removed. Okay. However, if you don't do anything with it, then then it doesn't matter. So like right here, like even though I took green beans out of the array list, I didn't do anything with it. I didn't print it. I didn't initialize a string with it. So it was just gone. Okay. But it still did its job. It still does its action. It's just the return was wasted. So like right here, when I said remove 2, I took at that point, which was, I guess, lettuce out of the list, right? Broccoli was 0, asparagus was 1, so lettuce was 2. Lettuce came out of the list. I just didn't do anything with it, but it still did the action. So now the list has shrunk down to size 3. And in fact, if we printed the list again, notice it only printed broccoli, asparagus, and cauliflower. Everything else was gone. About the only method I didn't show you here was the get method. And so if I was using the get method, say I said get 1, it's now not going to print this entire list. It's only going to print the item that it's retrieving from index 1, which in this case would be the asparagus string. Okay. I could have also initialized a string with that get method, because any of those methods there, get, set, or remove, right, are going to give you back a type of the object matching the list type. So I could initialize strings with things that came out of this list. If I had made this a list of book references, which obviously wouldn't work here because I don't even have a book class, but then anything coming out of it would have been type book. so I could initialize book in, variables with this. Okay. All right. Yeah. So there's a lot more code here. I'm just going to let you kind of look at that on your own. Just I gave you a lot of examples you can play around with. Let me know if you have any questions.